T-minus 10, 9, 8. We have a go for main engine start. We have main engine start. 4, 3, 2, 1, 0, and liftoff. Liftoff of the space shuttle, and it has cleared the tower.
It is slow. That's the case.
Reindeer touchdown.
Whoa, there she goes. STS-40, the first space laboratory dedicated entirely to life sciences research. We were pioneers. Oh, excuse me, where are my manners? Let me introduce myself. Ari Jellyfish here. Ari's short for Aurelia, my family name. We jellyfish go back 500 million years, you know. I consider our finest hour the Columbia mission in June 1991. Yep, there were 2,478 of us on that flight. Of course, we were a lot smaller then, just little polyps. There was plenty of room until 7 astronauts climbed aboard. But we couldn't go anywhere without them. Oh, sure, it got a little crowded, but we were glad to do it. After all, we were making history. We were helping NASA learn more about living in space. Oh, I know what you're saying. What's the big deal? It looks easy floating around up there. Looks like a barrel of laughs. But living in space is difficult. In the early days of space travel, there was so much we didn't know. Before humans traveled into space, animals were sent, while scientists checked their responses. When the first animal space travelers returned to Earth, they brought back enough information to safely send the astronauts into space. But even when NASA sent John Glenn to orbit the Earth in 1962, they still didn't know exactly how his body would react. Of course, as more astronauts were sent up, scientists learned more about the effects of space travel in relation to life sciences. Life sciences? Well, basically, that is the study of living things, how they grow, function, and interact. Scientists knew that more research needed to be done in space. And that's where I came in. I was part of an important NASA study on the effects of microgravity. Microgravity is the word scientists use to describe what happens to objects in a free-fall orbit. In other words, they float. Let me explain. Here on Earth, we feel the effects of gravity almost everywhere. You can experience a similar environment to microgravity if you go underwater, like me. Unfortunately, you can't stay underwater for long periods of time. You can experience microgravity on a roller coaster ride like this, or train like the astronauts do in NASA's special training airplane, the KC-135, that flies up and down. But the problem is that simulated microgravity only lasts 15 or 20 seconds. In space, microgravity lasts for as long as you're in orbit. You drift all over the place, and it's hard to tell if up is really up and down is really down. So it's difficult to predict how body functions will react. That's why scientists conduct experiments to learn more about microgravity. When they decided to use jellyfish for the microgravity experiment, everybody asked, why jellyfish? Well, hey, why not? You know, we are similar to you in a lot of ways. And one of our best friends, a scientist, knew we were special and could contribute a lot to science. Dr. Dorothy Spangenberg is the real expert who made it all happen for us. She's been hanging around with us for years. She knows everything about me, raised me from a little polyp. Dr. Spangenberg and her students worked with us for years before we actually flew in space. She began her research more than 2 decades ago, collecting us along the Texas coast. And people from all around the world sent her different types of jellyfish to study. That's why they call her the Jellyfish Lady. And the more she learned about us, the more she knew NASA could learn a lot from us because of our similarities to humans. But you should hear this from someone who saw us in action, Dr. Millie Hughes Fulford.
Thanks for the introduction, Ari. Hi, my name is Dr. Millie Hughes Fulford. I was a payload specialist on Spacelab Life Sciences. I'm here today in the Monterey Aquarium in Monterey, California, where another team of researchers are learning more about jellyfish every day. Jellyfish are among the simplest organisms, but they have neurons, or nerve cells, similar to humans. They have sensors, called gravity receptors, located in their arms, that help them maintain their balance and know where they're going. Think of it as a built-in compass. The gravity receptors tell them up is up and down is down. Humans have this too. To help us maintain our balance, there are gravity receptors located in our inner ear. Have you ever ridden an amusement park ride that spins you around? When you get off, you feel like you're going to fall down, right? That's because the motion affects your inner ear. Even after you stop moving, fluids in your inner ear keep moving. This makes you dizzy. This type of motion sickness affects astronauts in space as well. By learning more about the development and function of gravity receptors, scientists hope to fight the effects of space sickness. By sending jellyfish up in space, we hope to find out if they would react differently in microgravity than on Earth. Would they know up is up and down is down? And there are even more ways jellyfish help us learn about living in space. Astronauts returning to Earth also suffer from a calcium deficiency. We need calcium to keep our bones strong. Extended calcium deficiency causes osteoporosis, a bone disease, and many gum diseases as well. Each jellyfish gravity receptor has a sac of calcium sulfate crystals, just as our inner ear has calcium-containing crystals. On SLS-1, we wondered if jellyfish would suffer a calcium deficiency too. But these weren't the only reasons the jellyfish were chosen to fly with us. It was their small size that made the difference. We wanted a small animal we could study as it developed in space. Did you know that more than 100 jellyfish polyps can fit on a dime? The jellyfish is also easier to study because it develops in distinct individual phases, from polyp to ephira, and finally to medusa, the type most commonly seen in the ocean. It takes from 6 to 8 days for a jellyfish polyp to develop into an adult ephira. And we know it takes 9 months for a human baby to develop, and about 2 years for a baby elephant to develop into maturity. Can you imagine if we filled the orbiter with baby elephants for this study?
Holy cow! Or should I say holy elephants? What a mess! We were certainly a lot easier to work with than baby elephants. However, we still needed special preparation for space travel. We underwent months of training with the astronauts. They studied our appearance and development so they would know just what to look for when we were in space. And when launch day finally came, we were ready. Of course, I was back in the payload bay. To get a bird's eye view of all the action, let me introduce you to another member of the flight, Dr. Tammy Jernigan.
Thanks, Ari. Hi, I'm Dr. Tammy Jernigan. I'm in the Space Lab trainer here at the Johnson Space Center in Houston, Texas. I was a mission specialist on SLS-1, coordinating all the payload operations and carrying out the mission objectives, in this case working with jellyfish.
When people travel in space, we have to take our environment with us. We have oxygen, food, and everything else we need to protect us from the elements of space. When jellyfish travel in space, they need to take their environment with them as well. The jellyfish on board SLS-1 were placed in specially prepared bags filled with salt water and carried in an incubator to stabilize their environment. Just before we launched, Dr. Spangenberg and her students poured an iodine mixture into some of the bags to encourage the jellyfish's development. After all this planning, we wanted to be absolutely certain that the polyps would develop. By the time SLS-1 settled into orbit and we had begun our experiments, the jellyfish had passed their first important test with flying colors. They survived the launch, proving a smaller organism can withstand the forces of liftoff. To help the jellyfish polyps develop into Ephyra, we added the iodine mixture to another group of jellyfish. While we conducted experiments in the orbiter, simultaneous research was taking place on the ground by Dr. Spangenberg and her students. The Earth research is called the control, a setup that doesn't have the variable being tested. Every experiment should have a control because it gives you something to compare your results against. Both groups of jellyfish were videotaped as they swam in hopes of recording any changes in their movement or behavior. One of the most exciting changes happened almost right away. Remember how the jellyfish use their arms to pulse up and float down to feed on Earth? In microgravity, the jellyfish moved in circles, but they were still able to pulse and swim easily. In fact, despite being in a microgravity environment, the jellyfish polyps appeared to develop normally. After 9 days in orbit, we began to prepare the jellyfish for the trip home. One group was secured in the locker to be immediately studied after landing. The second group was preserved in a special liquid to be studied and compared to the jellyfish used in Dr. Spangenberg's simultaneous Earth experiment.
The information we gathered on SLS-1 will help us to learn how to fight the negative effects of space travel and pave the way for astronauts to stay in space for months or even years at a time. Pretty exciting, right, Ari?
You said it, Tammy. Boy, those 9 days just flew by. But this isn't the end of our story. Once we landed, Dr. Spangenberg spent more than a year studying and comparing us to our Earthbound jellyfish, and her results surprised everyone. After swimming in circles in space, some of us still swam a little funny after we returned to Earth. However, most of us went back to our old ways pretty quickly. Scientists believe that our gravity receptors function differently, which made us more sensitive to microgravity. The exciting news is that we can develop from a polyp to an Ephyra in space. When they studied our cells, they found most of us were completely normal. Oh, I hear you. You're saying, hey, what does this mean to me? Well, the more scientists on Earth understand how cells, the basic unit of life, develop, the more they can learn about human bodies and their responses on Earth and in space. They'll also learn more about the human immune system and how it fights diseases. They'll learn more about your body and the amazing things it can do.
Just think, we can learn all this from a little jellyfish. It just goes to prove that science is like a puzzle. It takes many pieces to finally get the big picture. This mission was such a success, NASA is already planning to send more jellyfish up in the future. By bringing together more pieces of the puzzle, perhaps one day more of the mysteries of space will be revealed.
And my children and you will be there to experience it all.